Hey guys, this is Miss Mo. Sorry, the phone rang. We were on this. Whoa. Okay, so the 12 I got from this 3. I multiplied all these top numbers, and then we were just talking about that there were 9 letters in this bag that I could choose from. So part over the total, or part over the whole, and piece over the total. That means you put a small number over the big number, the total number. So our first probability for the letter R was 2 over 9, because there's 2 R's and there's 9 total letters. Then for the second sucker, for the E, we said, well, there's 3 E's possible. But if you took out a letter from this bag and did not put it back in or replace it, that means the totals have to go down by 1. So for this probability of getting an E, well, if you already pulled 1, it's not 9 totals. It's not 9 total letters anymore. There's 1 less, so we need to put an 8, and then keep going. 7, 6, 5, 4, 3, 2, 1, and that's where this massive number comes in on the bottom. Okay. So we're going to multiply 9, 8, 7, 6, 5, 4, 3, 2, 1. So if this is too dirty for you, let's see, the probability of getting an R was 2 over 9, because there's 2 9s, 2 R's, and there's 9 total. The probability of getting an E was 3 over 8, because there's 3 A's, and if I pulled 1 out, there's 8 total now. And then it keeps going. And you keep multiplying. 1 over 7, 1 over 6, 2 over 5. You get the point. I'm about to run out of room. So we already did the top. It was 12. Let's do the bottom. 9 times 8 times 7. Oh no. Hola. Times 7 times 6 times 5 times 4 times 3 times 2. Wow, that's big. Let me try again. Okay, 9 times 8 times 7, 6, 5, 4, 3, 2. Okay, I guess that was it. Okay, so this is a freakishly big number. It's not what our answer is, but it's because we haven't reduced yet. So let me put this sucker down. Okay, and then we're going to try and reduce it. Well, I know both of these are even, because the top sucker has a 2 at the end and the bottom has a 0 at the end, so they're definitely even. So we could either try dividing by 2 and then keep going down, down, or if I could find something bigger that I could divide by, I could. Let me see if maybe this 362,880 could be divided by 12. Hot dog, it can! Okay, shall we divide it by 12? That was a lucky break, wasn't it? Okay, so we get 1 over 30240. Hey, okay. So this is the probability of pulling 1 letter out at a time to make up the exact word represent from all these random letters in a bag. Alright. Let's keep going. Oh, and on this one it says type an integer or simplified fraction. So again, we're not putting a decimal. If it says simplified fraction, you gotta put a fraction. Alright, number 5. It says 2 dice are rolled. Find the probability that the score on the dice is either 9 or at most 4. Okay, so I think we're going to omit this one because it doesn't have the word sum in it, and this is supposed to say find the probability that the score on the dice either adds up to 9 or adds up to 4, but it doesn't say the word add or the word sum. So let's delete this. I'll delete this from the test. Woo! And I'm going to delete it because it didn't quite say the word sum or add, and I'm afraid we won't know what to do. Alright, let's keep going. The next sucker says, when a single card is drawn from an ordinary 52 deck, find the probability of getting a black card. Okay, so here are our cards. Half of them are black, half of them are red. Yeah, that's pretty much the probability. But let's see if we can get that from doing the big boy math. Okay, so the probability of getting a black card is the number of black cards over the number of the total cards, or the part over the whole, or the piece over the total. Either way. So there's 52 cards in a deck, because they just told you that, 52. But then y'all need to remember that half of those suckers are black. $26. And this topic is kind of hard to teach to kids because they might not know about a deck of cards. Okay, so we get 26 over 52, but if you look, that's not an answer choice because we need to make it smaller if we can. Let's divide by 2. And I think we get 13 over 26. Oh my goodness, I think we can divide by 2 again. Nope, we can't. Now we can divide by 13. My bad. And we get 2 on the bottom. Let's see. If we divide 13 by 13, you get 1. 26 divided by 13 is 2. Hey, 1/2. And that kind of makes sense because on a deck of cards, half of them are black, half of them are white. Half of them are black, half of them are red. Okay, technically they're all white, I guess. Okay, number 7, it says a bag contains 19 balls numbered 1 through 19. I'm just going to go ahead and write this down because I know I need to do it anyway. Then it says, what is the probability of selecting a ball that has an even number? Okay, well, our probability is the part over the whole, or the piece over the total. Okay, so how many total numbers are there? 1, 2, 3, 4, 5, 6. Oh, okay, yeah. 19! Okay, now we need to find the part that is even numbers only. So let's count how many evens we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 9 evens. Okay, the last thing is, can we reduce? No, because 19 is one of those weird prime numbers. Hey, that one with a dead end. Okay. Let's see here. It says, number 8, each of 10 tickets is marked with a different number from 1 to 10 and put in a box. If you draw a ticket from the box, what is the probability that you will draw a 2, 3, or 1? Okay? There's a secret word in here that tells us whether we're supposed to add or multiply or whatnot. And the secret word is or. If you remember back from the very first page, number 3, we said something about union meaning or adding, or another way to say it is count. How many? Okay, so let's see here. We have a box, and there's 10 numbers in there. Yeah, okay. And it says, if you draw a ticket from the box, what is the probability? Well, that's the part over the whole. So, how many numbers are in this whole box? 10. Okay. Well, what's the part that just is a 2, 3, or 1? Well, how many is that? The 2, 3, and the 1, those are 3 numbers. So we're going to put 3 on top. And hey, that's it. 3 over 10. Hey, if they would have said 2, 3, 4, 5, or 1, how many would that be? What would the probability for this be? Well, the whole, or the part over the whole, the bottom of the denominator, would still be 10. And then the top, we would count how many. 1, 2, 3, 4, 5. There'd be 5 numbers out of this box that were 2, 3, 4, 5, or 1. And then that reduces to 1/2. So, okay, but that's not the actual problem we did. We just did this one. Alright, number 9. It says 2 marbles are drawn without replacement. So without replacement, that's the same word that we saw on number 4, without replacement. And on number 4, that meant our totals go down. Okay, so first let's add up the total amount of marbles. There's 3, plus 2 is 5, plus 2 is 7, plus 1 is 8. Okay, it says find the probability that the first marble, okay, so let's talk about this first marble. Here's my first marble. Yeah, and we want to know what his probability is, and he is for blue. Okay, well, we're going to do the piece over the total, or the part over the whole, or whatever I keep saying. Okay, so how many blues are there? 1. Over how many totals? 8. Okay, good. Then let's talk about the second marble. This second marble is also blue. Well, let's think about this. Without replacement from the box. That means if you take a ball out, you don't put it back in. As in, the totals go down. So this 8 now becomes a 7. Okay, now let's think about this. How many blue balls were there all oh my gosh, how many blue marbles were there all together? There was 1. Yeah. Well, if I take that one out, I don't have it anymore, and it's just a 0. So it's kind of like when we were doing this represent problem where the totals went down by 1, 9, 8, 7, 6, 5, 4, 3, 2, 1. And the possibilities went down by 1. So like for this R, it said 2 over something. For the next R, it said 1 over something. Yeah. Or for the E's, we had 3 over something, 2 over something, 1 over something. You see they get smaller by 1. Same thing here. Since it says without replacement, that means you have to subtract 1 from the bottoms, so 8 becomes 7, and the tops. 1 becomes 0. Okay, the last thing we need to know is this word and. And means multiply. So we're going to say 1 over 8 times 0 over 7. And when you multiply, you go left to right. So 1 times 0 is 0. 8 times 7 is 56. No. 8 times 7 is 40. Yeah, 56. Oh my gosh. Okay. And then if you try and do 0 divided by 56, it should be a thing. It's 0. So if you wanted to know how to type this in your calculator, 0 divided by 56 is the number 0. And you might be saying, wait, hold up. Why did we all of a sudden divide right here? Because all these other ones we kept as fractions. Well, let's say I didn't divide. Let's look over here at our answer choices and see which ones are definitely not it. 0 over 56? Yeah, that's not 1 over 7. 1 over 20? Yeah, that's not it. 1 over 8? Yeah, that's not it. Yeah. So, the only other option it could be is 0. And if you want to check yourself, you can say 0 divided by 56, and yep, it's 0. Alright, let's keep going. Number 10, it says, what is the probability that the arrow will land on an odd number? Okay, well, we do the part over the whole, or the piece over the total, or whatever. So let's see here. How many odd numbers are on this spinner thingy? There's 1, 3, 5. Oh, so that's 3 odds. Okay. How many total spinners are there? How many total sections are there? 1, 2, 3, 4, 5. Hey, that was the easiest one, right? Yeah. Okay, let's look at this sucker. It says, what is the probability of spinning an A? Whoa, these are weird. Okay, I got this A. That's 1. Here's 2. Here's 3. Okay, so we're going to do the part over the whole. How many A's are there? 3. How many total are there? 1, 2, 3, 4, 5, 6, 7. There's 8 total. Hey, bam, 3 over 8. Nice. Okay, number 12. It says a fair dice is tossed. What are the odds in favor of the cube showing a number less than 3? Okay, here's this little formula. Probability of A over 1 minus the probability of A. We did this in our 9.3 section. Here they are. Only we kind of stopped using those symbols and just said, okay, it's the probability of what we want over what we don't want. Yeah. So let's look at this. It says odds in favor of the cube showing a number less than 3. Okay, well, let's think about cubes. Here are cubes. Yeah, that's a dice. And what does the dice look like? There's either 1 dot, 2 dots, 3 dots. You get what I'm saying? That's what a dice is looking at. So, what numbers are less than 3? Well, there's the number 1. That's less than 3. What else is less than 3? 2. Okay. What else is less than 3? Nothing. If it would have said less than or equal, then I would go ahead and write down 3. But this just says less than. Okay, so this is what we want. How many numbers did I write down? 2. Okay, what are the rest of the numbers on the dice? Because whatever they are, we don't want them. So, the not wanted numbers are everything else. 3, 4, 5, 6, 7. Oh, don't. Remember, dice don't go to 7. They just go 1 through 6. Okay, so we put the amount of numbers that we want. The number 1 and 2. That's 2. Then the amount that we don't want is 1, 2, 3, 4. This is 4 numbers. Okay. Reduce, reduce. Reduce, reduce. It makes 1 over 2. Okay. And then that doesn't really look like these. But we just have to turn that bar into a semicolon. So it makes 1 semicolon 2. Or is it colon? I don't know. Anyway, dot dot. Alright, number 13, I'm going to delete because I think it was supposed to say the word sum, S-U-M, or the word add, but it didn't say that, and it's not super obvious, so I don't want you to do that one. So I'll delete this from your review. And your test. Okay, next sucker, number 14, it says a bag contains 19 balls numbered 1 through 19. What are the odds in favor of selecting a ball that has an even number? Okay, so how many balls are there altogether? There's 19, yeah, okay, but I want to know how many are the ones that are even that I want. Well, let's see here. The numbers that I want are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, not 20 because we're just talking about a bag that contains the balls numbered 1 through 19. So this 20 is not even in the list. Okay, so we stop at 18. How many of these numbers was that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now let's see, what are the numbers we don't want? Well, if the numbers we want are the evens, the don't want are the odds. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. Oh, nope, you can't go past 1 through 19. So let me cross out that 21. Okay. So how many numbers did I just write down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, there you go. And then just kind of turn it sideways and put a colon, semicolon, whatever it's called. Hey, there we go. 9 to 10. So whatever is on the top goes on the left. Whatever's on the bottom goes on the right. All right, let's keep going. I think the rest of this is pretty easy. Okay, it says a website posts evaluations on professors. How nice. It posts the most positive and most negative comments for each professor. Okay. What about all the stuff in the middle? Okay. Discuss the usefulness of this feedback for a reader wanting to know about the professor. Okay. So first of all, do we think that this is a good way to tell whether you should take the teacher or not? Nah, because it leaves out all that middle stuff. Maybe there's 1 positive and 3 negative, but 114 good jobs. So this is not an accurate way to decide what teacher you're going to use, because you're missing all that middle stuff. So this is not a good way. So let's cross out the one that says the reader can accurately, because no, you can't. You're missing a bunch of the data. Okay, so everything else says cannot accurately, and we need to understand why. It says the reader cannot accurately assess the professor without reading all of the evaluations. Okay, all of the evaluations, it could be, millions of evaluations. It's like Amazon reviews. There could be tons of them, and you don't want to read every single one of them. So we can't even read all of them. Because there's so many. So that's an inaccurate statement. We don't want to choose that. That is why, it's true that we cannot read all the evaluations, but that's not why you would choose the wrong professor. Okay, let's look at these next ones. It says the reader cannot accurately assess the professor because the method of choosing the sample is unclear. Okay, so the sample is the positive and negative comments. And it says the method of choosing. Okay, well, when we want to inform someone of something, we don't just include the positives and the negatives. We need to include a nice sample from all of the reviews. We need to grab some positives, some negatives, some in the middles, and not only that, it needs to be random. Okay? So, this says cannot accurately assess because the method of choosing the sample is unclear. We don't know whether it was random. It doesn't seem random because it looks like they just chose all the positives and all the negatives. If they would have chosen random comments, then it would be a good way to decide on your professor. Okay, the last one says the reader cannot actually accurately assess the professor because the evaluations posted are not necessarily representative of all evaluations. Okay, so the point is, we don't have to read all of the evaluations. That's not why what this website did was wrong. That's not why it's wrong. No one ever expects you to read all of the reviews. So we mark that out. Okay? The reason that this website did something wrong is because they did not pick a mix or comments that were representative of the population. So when you get to this test question, if it says they're just looking at, maybe the lowest and the highest, well, that's not cool. You need to pick something that is representative of the whole population. So look for the word representative of all evaluations, because that's what we need. We need some pluses and some minuses and some mixtures. And then also choose the one that says this method of sampling is unclear, because it has to be random. And if they didn't say random, how do we know it's unclear? Okay. And again, part A is wrong because no one ever expects you to read all of the evaluations. As long as you have something random and representative, then you're doing okay. Okay, let's look at number 16. It says, to determine the student's preferred mode of transportation, which sample is more likely to be random? Ask students all over the country. Ask students that live in your city. Okay. Well, if you ask students that live in your city, is that representative of the whole population of students in the world or in the country or on the continent? Nah. Okay, so it says which sample is more likely to be random? Not quite this B, because this is not representative of the population. For example, maybe someone who lives in Highland in Dallas really likes to ride the city bus because it's free. But somebody in Greenville, Texas doesn't like to ride the city bus because we don't have one. So you have to include the whole population. Okay, so we said B is out because it's not representative of the whole population. We need people from everywhere. So sample B, whatever says that, is out. Okay, let's look at what says sample A. Part A says more likely to be random because the chosen sampling location is random as well as the people being sampled. Okay, part B says sample A is more likely to be random because fewer people are being sampled, so the data will appear more at random. Okay, it did not tell us how many people we asked from the country, and it did not tell us how many people we asked from the city. So this whole fewer, that word fewer, that means we know exactly how many students were asked the question, but they didn't tell us which students, how many of each. So this sucker is wrong because they did not even tell us the actual number of people. So how can you choose that? Because it says because fewer people are being sampled. We don't know if one had 20 students ask the question and the other had 100 students being asked the question. We don't know. It didn't tell us. So we're definitely not going to pick that one. Yeah. So we're going to pick part A that says it's more likely to be random because the chosen sampling location is random as well as the people being sampled. Okay? If we look about the country, and you ask students from all over the country, you're going to get all types of random answers. Somebody from Greenville, Texas is going to say, I like my car. Somebody from New York City might say, I like a taxi. Somebody from LA might say, I like an Uber. So, if we ask people from all over the country, you're going to get more different answers. or more random answers, more different answers, and you're going to be able to ask a better randomness. If you went to LA and you said, how many of you, or what's your preferred mode of transportation, a lot of people are going to say Ubers because everybody takes Ubers, but we need some randomness in our sample. So we need to pick it from over the country, because that way we'll get people who prefer an Uber or the free bus or their mom's car or this, that, or the other. Okay, let's keep going. 17, it says Coach Garcia kept track of the jumping records for the basketball team for a 10-year period. Draw a line graph for the data. Okay, so first it says at 2003 we're supposed to have 73. Well, let's see. Part A says here at 2003 we have, oh my goodness, something in between 80 and 90? That ain't right. Yeah, okay. Okay, let's try this next one. This next one says 2003 is a little past 70. That makes sense. Okay. Yeah. Let's look at 2004. 2004 would be the very next tick mark. And then the tick mark after that is 2005. It looks like they kind of scaled it. They jumped around. Okay, so at 2004, Part B says we're supposed to have something like close to 90. And we don't. It says 2004 is supposed to be 74. So that one's wrong. Okay, let's go to C. Well, it's the only one, and it's right. So for 2003, we're supposed to have 73. For 2004, 74. Let me jump to the back end. 2012, we're supposed to have 87, which is kind of close to 90. So, yay, that one was super easy. It was just an eyeballer. All right, let's keep going. Number 18, it says the graph below shows the number of marriage licenses issued over a 6-month period. Which months differ the most in the number of licenses issued? By how much did they differ? Okay, when we say differ the most, that means how much are they different? How are they different? Okay, well, first we got to figure out what all this means, okay? For March, it says it looks like a circle and half a circle. And underneath it says it represents 20,000 licenses. Okay, so this is definitely 20,000. And then what's half of 20,000? It's 10,000. Okay, so this March is 20 plus another 10, and that makes 30,000. Okay, what about April? April is 2 circles, so that's 20 plus 20 is 40,000. The next sucker is 4 circles, so that's 4 times 20, or 80,000. Then we got 1, 2, 3, 4, 5, 6 circles. So that makes 6 times 20 is 120,000. Then 3 circles means 20, 40, 60. Then a half means another 10. So 70,000. And then lastly, 20, 40, 60, 80, and another 10 makes 90. Okay, so it's asking which months are the most different. Like what's the biggest month and the littlest month, because they will be the most different. Okay, well, let's see the biggest. The biggest is this 20,000 for June. What's the smallest? Looks like March for 30,000. Okay, so we definitely got that. And then to figure out how much they differ, we minus Okay, so 120,000 minus 30,000 is 90,000. Yeah. Okay, so again, we got this from the biggest and the littlest, and then we had subtract them to get that 90. Okay, let's keep going. Number 19. It says the midterm scores for the 7th period typing class are shown in the dot plot below. What are the low and high scores? Okay, well, this means that this X over this little tick mark means that was a 56. Somebody made a 56. This next tick mark right before the 70 means somebody made a 69. And then so forth and so forth. So the lowest is this 56, and the highest is not this 100. It's where the X is. So this highest is, I gotta count, 95, 96, 97, 98. Hey, B. That one was super lame. You just gotta be careful on how you count. Okay, number 28. The weights in pounds of a group of high school students are listed in the stem and leaf plot on the right. What is the difference between the lowest and the highest weights? Okay. Well, remember that this 9 bar 8 means 98. And then on that same line, 9 bar and the 9 means 99. Then way down here at the bottom, this 15 bar 1 means 15-1 or 151. Then 15 bar 6 means 15-6 or 156. Then 15 bar 7, 157. 15 bar 9, 159. Okay, so the lowest and the highest, these are already in order. Smallest to biggest, 9, 10, 11, 12. Yeah, okay. So the lowest comes from this first row, and it's whatever this 8 is, as in 9 bar 8, 98. The highest comes from the last row, and it's what the very last number is, because that's the highest number, 159. Okay, so we got 98 and 159. Now it says, what is the difference? Different means, how do they differ? Do you have to add or subtract, or what's going on? Well, let's go ahead and minus these and see how much they are different. So we do 159 minus 98, and we get 61. Hey, and if we would have done it bass-ackwards, like 98 minus 159 on accident, we would have gotten negative 61. But just remember that we haven't even talked about negatives in this class yet. So it has to be that 61. Okay, keep going. The next sucker says, the bar graph shows the number of students by major in the College of Arts and Sciences. How many students are in the College of Arts and Sciences? This is what you are in. If you are a math major, you are in the College of Sciences. If you're a teacher, you're in the College of Arts, because it's kind of it's considered an art. Anyway, so when you're a teacher and you get a bachelor's degree, it'll be a Bachelor of Arts. What? Yeah. Mine's a BS because I didn't actually go to college to be a teacher. Okay, anyway, let's go. How many students are in the College of Arts and Sciences? Well, it's not 500 over here on this top. I know you see 500 as the highest number and you want to use that. No. That's just the scale for how high these bars go. So, how many math majors are there? How high does that bar go? 200. How many history majors are there? How high does that bar go? 300. What about English? How high does that go? 400. Keep going. Science is maybe 150. Other is, maybe 175. I don't know. Just kind of round. Okay, now we're going to add up these all together. And that should give us this 1225. Bam! Okay. Next, 22. It says a double bar graph. Below shows the number of male, they're the M's, and F, female athletes at a university over a 4-year period. What is the only year in which the number of female athletes declined from its previous value? So declined means goes down, as in the bar is lower. Okay, well, we're talking about females, so let's see here. This first bar from 1986 to 1987, we went up. So that's not declined. Okay, so from this first red bar to this second red bar, we went up. That does not show a decline. Okay, from this second bar to this third bar, we went up. That does not show a decline. But lastly, we from the F bar to the F bar, we went, oh no, down. That means we declined. So it says, what is the only year in which the number of females declined from its previous value? So we're asking for the year when it declined from its previous value. Well, we're not going to say 1988, because 1988 has a year that has a bar that's higher than the previous bar. So we're not going to say 1998. We're going to say 1989, because that's the year whose previous bar was higher. Or we're going to say 1989 because its previous year was higher and we ended up declining. Okay, so anyway, 1989. Alright, let's go. Number 23, it says, in a school survey, students showed these preferences for instructional materials. The results are shown in the circle graph on the right. About how many students would you expect to prefer computers in a school of 400 students? What? Okay, so this is a survey about a school. There's 400 students. That means there's 400 total. Okay? It's asking about computers. Let's look at what percent of our people liked computers. So computers is blue, and it's 36%. So that's 36% of the total. Okay, well, what is the total? Okay, well, there's a couple of different ways we could do this. The easiest way is just to say 0.36. Where did I get that from? I can't type 36% symbol in my calculator. I cannot type a percent symbol in my calculator. So I have to take that decimal and move it twice to the left. So 0.36 times 400. This is the easiest way to do it. But some of you like making proportions. So if you're going to do the proportion, don't forget to do the part over the whole. As in, I know there's 400 kids in the school, in the whole school. I don't know how many like computers, though. But I do know that the computers are worth 36%. And how many total percents are there ever? We can only ever have a total percent of 100. Okay, so this is a way you can set up a proportion. Or if you turn this around, these are all the different proportions we could have. So if you wrote 36 over question mark and 100 over 400, you can do, yeah, that's totally cool. 36% over computers question mark equals 100% over 400. This is another possibility for your proportion. Or I could turn it sideways and have 100 on top of a 36. Equals 400 on top of your computers. So, either way, with whatever proportion we use, we have to multiply the diagonal that has both numbers in it. So not this comp 100, we need to multiply 36 times 400 and then divide by 100, because that's the number from the other diagonal. Or if you were using this middle proportion, we have to multiply the diagonal, 36 times 400, and then divide by what's in the other diagonal, 100. So, either way, let's go. I'm just going to do this first simple way. 0.36 times 400. 144. So 36% of this picture was 144. You might be able to kind of just think of that using your brain, because let's think about this. If the total circle is 400, what's half the circle? It's 200. Yeah. And this little smidge, okay, so half of the circle is 200. What if we halved that half? That would mean each half was worth 50. Each half was worth 100. So that might, if you didn't understand any of this proportion or the multiplying, you can just kind of use your common sense that a fourth of this circle, 1/4, 1 out of 4 fourths is 100. So this right here is definitely 100 plus a little bit more. And B is the only answer choice that has 100 plus a little bit more. Or you could use the mathy way. Okay, let's keep going. 24, it says, here's a graph. And we want to know what type of association is this. Well, if it goes up from left to right, it's positive. Kind of like if you took college algebra, lines that look like this have positive slopes. Yeah, okay. But then if I had a graph whose dots were kind of like this would be negative. Okay, but then if I had a graph with just all over the place, that's no association, okay? But ours is positive because it's going up. Woo! All right, 25. I should probably take a break. Okay.